Yes, no, maybe remember,
Hi.
not remember.
Yes.
Okay. Now what I'll do, ps-ef grep postgres. Is my PostgreSQL running?
Yes, now it's running.
How can you say that it is running?
Uh, Here
Here,
iFund is there, right, with the path.
right. There is a big line with minus -d in between. It means my PostgreSQL cluster is running. I'll come here. That also indicates my postmaster is running. This is my postmaster. And then these are all my background processes. And then when you create a new session, psql-u username -d database name, I will open a new session, root res123, switch to Postgres, ps-ef grep Postgres. I see a new line getting created. This is your user backend process. So every time you establish a session, a new process gets created. That is your user backend process. Is this clear? So this is what we understood during the connection establishment session. Yes,
Yeah, yes.
right. Now we'll try to understand the architecture. First thing first, what is that user backend process does? Just to recap what happened the other day. When you have a database and when you have your table inside your database, let us say 1 comma a. In the front end, I entered my username, I entered my password, and I click on sign in. The request will go to the middleware. Middleware will contact your postmaster process. Postmaster, after doing authentication, it creates a new process called server process. And this server process will communicate with your client process. And the server process is the person who actually go inside the database, get the data, and give it to the client. Client then forward it to front end. Accordingly, you're taken to the next page, or you're thrown an error message that user exists or user does not exist. For example, I'll come here. Um, Shiva Prasad, go ahead. Um, I'll create a table, create table employee, ID int, salary int, insert into employee values 1 comma 100. Now what I'll do, I'll try to select the data, select the star from employee. But before getting the output, I wanted to wait it for, let's say 15 seconds, or let's say 10 seconds. Enter. Now what I'm doing, I sent select query from the client, and from the server, ps-ef grep Postgres, you see there is a select happening here. That means this confirms that your user backend process is the one that actually gone inside your database to fetch the data. Now my client shows up the data, which means the select is now completed. It is now become idle. I'll try to do it again. Come here. Idle has become select. So this is the person who actually gone inside the database to fetch the data. These are all the associated processes. Each has their own work to do. And postmaster is the ringmaster who controls everything. Right. Any questions here? ठीक है. I don't know if you are joining for the first time. There is nothing like quick Q&A at the end of the discussion. Please ask me questions then and there. There is nothing like Q&A. We'll do it later. Right? You have a question, you ask. PostgreSQL architecture consists of three main components. One is your memory, background processes, and physical files. Memory is again divided into two: local memory, shared memory. Local memory is again divided into three: workmem, maintenance workmem, temp buffers. Shared memory is again divided into three: shared buffers, wall buffers, and commit log buffers. Your background processes: postmaster, background writer, checkpointer, wall writer, auto vacuum launcher, and user backend process. Physical files again divided into three: data files, control file, wall files. PostgreSQL architecture consists of three main components: memory, background processes, and physical files. Memory is again divided into two: local memory and shared memory. Background processes are divided into 5 or 6: your postmaster, background writer, checkpointer, wall writer, auto vacuum launcher, user backend process. Your physical files, you have data files, control file, and wall files. This is your RAM. This is your CPU. This is your hard disk. Is this clear? When someone asks you, explain me the architecture. PostgreSQL architecture consists of three main components: memory, background processes, and physical files. Memory is again divided into two: local memory, shared memory. Local memory is again divided into three: workmem, maintenance workmem, temp buffers. By this time, your interviewer stops you explaining and asks you uh, explain in detail about, let's say, shared buffers. What is shared buffers? What is wall buffers and all that stuff. Don't jump here and there. When you're explaining the architecture, PostgreSQL architecture consists of local memory and then data files and then wall file and then wall writer, then go back to temp buffers. Don't jump here and there, right? Now we'll understand the architecture and its components by using the four main queries: select, insert, update, and delete. First, what I'll do, I'll come here. This is my memory. These are my background processes. This is my physical files. PostgreSQL, as we discussed the other day, it is just like any other software that you install in your computer. It works on the same fundamental rule. Every time, let's say you install your software, you want to use it, you double click on it, it will be fetched to your memory and it is displayed on your computer screen. The same thing. This also follows the same rule. Who is going to fetch that? Your CPU is going to fetch that. Where it is going to put it? In your RAM. Where it is permanently stored? It is in your hard disk. You wanted to play a movie, you will use a VLC player. For example, your movie is there in your hard disk. You double click on that movie. It is fetched to your RAM. Who will do that? Your CPU. And you will watch it on your computer screen. And when you are done, you close that movie or VLC player. The movie is again brought down to your disk. The same rule applies here as well. This is my hard disk. Let us say this is my table 1, 100, my control file, my wall file. This is my user backend process, and then background writer, checkpointer, CKPT, wall writer, auto vacuum launcher. And this is my RAM, shared buffers, and wall buffers. Now, what happens when you execute a select statement? I'll log in. I'll do something like this. Select star from employee. The first thing that happens when you execute a select statement is your syntax check. That's your first step. Now what I'll do, select star from FROM employee. The second thing that happens is your semantic check. Whether the table exists or not. If it is exist, whether the user who is trying to access has the permission to fetch the data or not. So when you execute a select statement, the first thing that happens is your syntax check. The second thing that happens is your semantic check. And then I'll do something like this, select a star from employee. Once syntax and semantic check is completed, your optimizer will create a plan to fetch the data and hand it over to your user backend process. User backend process is the one that actually fetch data from hard disk and put it in your memory 1, 100, and it is displayed on your computer screen. This is your third step. Who is performing third step? User backend process. And fourth step is displaying on your computer screen. That is this. Just to recap, when you run select query, the first thing that happens is your syntax check. Second is semantic check. This is called parsing. Once that is done, optimizer will create a plan how to fetch the data from hard disk to RAM, hand it over to user backend process. User backend process is the one that actually fetches data from hard disk to memory. That we have seen in our previous example when we tried select query. My PS-EF grep Postgres has actually shown select for that user backend process. And once the data is fetched, it has gone to idle. And after fetching it to your memory, it is displayed on your computer screen. That means forwarded to your client over the network or within the machine, whatever it is. And let us say I'm accessing the data from the remote machine. So this will happen over the network. I'll do something like this. Select star from employee. When you're doing it again, your syntax and semantic check will happen again. Plan generation will happen again. Only third step is skipped because the data is already there in the memory. It is directly handed over to your client. There is nothing like soft parsing in Postgres, which means every time you run a query, it undergoes syntax and semantic check. There is no plan storage, library cache, data dictionary cache, hash value, attachment, nothing like that. Any question in select statement?
Kumar, here involving any table space?
Table space. See, the location where you put your table is your table space in Postgres. So that is your hard disk, right?
Yeah, correct. Sorry,
This area.
I mean to ask like temporary table space.
Why temporary table space?
The shared buffer, it's taking any table space?
No, it is RAM.
Okay.
That's your RAM component area in your RAM. your 4 GB RAM or 16 GB RAM is there, right? In that 16 GB RAM, you are dedicating some amount of memory so that you put your data temporarily in that location.
Okay.
RAM is a volatile memory, right? Every time there is a system restart, your RAM is gone. You
Yeah.
put whatever in the RAM, that is gone.
Okay. And one more thing for system sysax table space Oracle like that. Is there anything?
That is what. That is at your hard disk level here, right?
Yeah. Yes.
If you have seen in the architecture just now, this is your physical files. In the physical files in Oracle, you have mainly 5 table space. 5 data files: systems, sucks, undo, users, and 10. But here it is unlimited. Each table is a data file here, and there is only one control file, unlimited wall files. You compare it with Oracle, 5 data files, 2 control files, 3 redo logs there. By default, you can change it any number, that's a secondary thing. But here it is by default unlimited data files. When I say unlimited, it is defined based on the number of tables you have. So there is nothing like your system tables will go to system or sysops, nothing like that. Even system tables are stored within the same folder separately.
Okay. This shared buffer data physically is there storing in same folder.
See, your metadata in Oracle is stored either in system or sysops at
Yes.
disk level,
Yes.
is stored in data dictionary cache in memory level. But here, even your dictionary gets stored in shared buffers in memory level. So this is the only component that holds all your tables, be it a meta table or user table. It goes something like to perform the semantic check, you need DB underscore users table, right?
Yeah.
Whether the user has access to the table or not to do this. So in
Yes.
Oracle, what will happen? You have a separate memory component.
Yes.
This is your database buffer cache, and this is your data dictionary cache. Your meta is stored here. That will help for you to do syntax and semantic check. Once it is done, a hash value is generated with the plan and all that stuff. It is stored here. Your actual employee table is brought to your database buffer cache. So your database buffer cache equivalent is your shared buffers. Do you think database buffer cache has a table space? No, right? Database
No.
buffer cache is a memory area.
No, I mean to ask like a shared pool has database buffer cache and library cache. The data dictionary data stores in
Correct.
system
There
table.
is no concept of shared pool here.
Yeah.
So shared pool is not there. Inside shared pool, your data dictionary cache is within the shared buffers in Postgres. There is
Oh,
no concept of LC. This is
oh,
completely not there.
okay.
Right.
Yeah. Okay, Kumar.
Any question on select statement? This is my table. I did select a star from employee. My optimizer has found 2 paths. This is path 1 to fetch the data from hard disk to RAM. This is path 2 to fetch the data from hard disk to RAM. Which one is the good path? Question.
Yeah, obviously first one.
This is the client 10.2. Let us assume this is my 10.1, my server. So which one is the best path? Right? Understood, everyone? The second thing, second thing. Let us assume my user backend process is the one who is actually fetching the data from hard disk to RAM, assuming that it has chosen the path 1 only. It has not chosen the path 2, right? It has chosen the path 1, so it has gone to your disk, came here, and understood that everything is busy here. All the buffers are occupied. So it has to clean few buffers and then place your data there. Let us say I wanted to bring employee table from hard disk to RAM. By the time I wanted to get the data from hard disk to RAM, there is already a department table that is existing in the RAM. It has to do all that LRU algorithm and all that stuff to evacuate the existing content from the memory and put your table in the memory. That's the second case. This guy is lazy. i3 processor. So he is bringing at, let us say, 2 kbps. Or he is busy bringing another data for another request. I have 8 CPUs. I made 16 connections. First 8 connections have already ran queries, and my CPUs are busy fetching that data to hard disk, sorry, to memory. And for this employee, for this new user backend process, there is no CPU available. That's a case 3. Your memory is full so that your user backend process is not finding the space in the memory. Your CPU is busy bringing another data for another request, and your current request is being on hold. Your optimizer has chosen path 2. And yeah, your network is busy. You're sending another data over the network. Your tunnel speed is hardly 2 Gbps, let us assume. Right, so these are all the areas that we see why the query is slow. Correct? Yes? No?
Yeah, correct. Depends on configuration.
This is my shared buffers. This is my wall buffers. My user backend process, background writer, check pointer, CKPT, and then wall writer, and then I have something called auto vacuum launcher. So in the select statement, did I use background writer anywhere?
No.
This is my data file, this is my control file, and this is my wall file. Now I'll come here, clear, select txid underscore current. What is this? This is the current transaction ID of the system. Every change you make to your database is assigned with a unique number that is called transaction ID. So you insert a record, delete a record, update a record, whatever it is. You make a change to your database, that change is uniquely identified with a number called transaction ID. So the current transaction ID of the system is 765. I'll do something like select star from employee. This is not a change. So this is not allocated any transaction ID. Now what I'll do, I'll try to insert a record, insert into employee values 2, 200. This 2, 200 is allocated with a unique ID or a transaction ID. 765 is already used. So 766 is the transaction that is attached. ID that is attached to your transaction. 766. I'll insert another record, insert into employee values 3, 300, 767. I'll update this first record. Update employee set salary equals to maybe 200, where ID equals to 1. This number will become what? Think and tell me. What that number will become? Understood? Do you want me to repeat?
768 and 4
760.
and ID will be 4.
No, ID will be 1 only, right? Now ID will become 4.
Sorry.
Yeah.
Yeah.
768. And this is your actual record. Right? Every time you make a change to your database, that change is uniquely identified with a number, and it is called a transaction ID. My current transaction ID is, how do I get the current transaction ID? I'll run this query. So current it is 769. That's occupied. So next transaction I'm going to do will get 770. If you are doing a transaction in begin and end, the number of changes you make, insert, let us say I'll do this. I'll do it again. I'll do it again. All these three will get a same transaction ID because you're doing in a transaction mode. That's the secondary thing. What is my current transaction ID?
Double 771.
771. That is used. So any transaction that I do will get 772. Next transaction that I'm going to make will get 772.
Like
Understood?
this is SCN.
Yeah, this is current underscore SCN from readAlert database. Yeah, this is current SCN. Right. Now exit. Clear. Assuming that my transaction ID for my 1, 100 is 1. This is my transaction ID, the first column, that is xmin. It's a pseudo column. 1, 100 is the actual record. Now what I do, I log in, begin, enter the transaction mode, update employee, set salary equals to 200, where ID equals to 1. That's the update that I'm making. When you do this update query, the first thing that happens is syntax and semantic check. And the next is, once the syntax and semantic check is done, it will copy the data within the table. 1, 1, 100. Why? This is to satisfy your isolation. What is isolation? Reads and writes should not interfere each other. So when you're reading the data, it will read the past image. We understood this during ACID properties. And it will put a star mark here. That means I'm modifying this data. What is this step? This is your third step. And then it will bring the data from hard disk to RAM. 1, 1, 100. What is this? This is your fourth step. And then modify the record. Transaction ID 1 become transaction ID 2. Salary become 200. After modifying the data, copy it to your wall buffers. 2, 1, 200. That is your fifth step. Once it is copied to your wall buffers, one record updated message is displayed on your computer screen. That means this one.
Kumar, in wall buffer, it will write only the updated data or both it will write?
It will write entire row data.
I mean, past image and recent updated one, both are?
It will copy entire block. It's a copy of the block, this block to here. It is not like Oracle, like you insert, it will write entire record. If you update, it will write only the updated record with primary key. If you delete, it will write entire record. Nothing like that. Here it will write everything. You can assume that it will write entire row data. Or your statement. You can assume that it is a statement. Your update statement it will write. Right. Now, once the data is copied, the block is copied to your wall buffers, there is no decoding concept here, right? During the instance recovery, we'll understand that later. During the instance recovery, it will copy the blocks and put it in your data files. You open it, understand the statement, decode it, make a SQL statement, you copy it, like that, nothing will happen here. Where am I? Yeah. This guy is going to bring it up. Any questions till step 5? Everyone? Just understand the flow. Any question till step 5? Do you want me to repeat? How can I?
Kumar, for that past image, is there any parameter to it should be stay this much of particular time, like?
What is past image? No, it will stay
mean-
forever. It will stay forever as long as the
Oh,
transaction is open. Even the transaction is closed, it will stay there only.
okay.
So there is no separate time. Others, any questions? Understood? Not understood?
Kumar, can you repeat that again, please?
Okay.
Yeah.
I have a record 1, 1, 100. I want to update it. When I write this query, update employee set salary equals to salary plus 100, whatever it is, where ID equals to 1. The first thing that happens is copy the data within the table. That is to satisfy isolation. Reads and writes should not interfere each other. And reads should always see the consistent past image. Since I'm going to update that record, while updation is going on, nobody should see the updated data, updating data until it is committed. So it is created a new copy and it is handed over to selects. So every time you run a select query, you will get the data from this. And then your record is fetched to your memory. It is modified in shared buffers and then it is copied to your wall buffers. Once the modified block is copied to your wall buffers, one record updated message is displayed on your computer screen. Now I have two options, either to commit or roll back. What I'll do, I'll commit. When you commit, the information in wall buffers is written to your wall file. 2, 1, 200. And this is your 6th step. Once it is written to your wall file, a commit complete message is displayed on your computer screen. A commit complete message on your computer screen indicates the modification has been written to your wall file, not to your data file. Is this clear? And after that, after certain amount of time, your background writer will get the data from shared buffers to data file. Your check pointer will ensure that your data is written to your data file permanently. When the data is written to your wall file, this star mark will go away, and this is marked as dead because this is no longer required because I have already committed. Now there is a new consistent image that is 21200. Any question in sixth step? Question in flow? Yes, no, maybe.
No, Kumar.
Right. Now let us slightly deviate from the architecture to understand the next steps better. Once the data is written to your wall file, your wall writer will inform the check pointer that it has written something from wall buffers to wall file. The check pointer, what it does, it updates that information in your control file. This is 7th step and this is 8th step on the right hand side section. Once it is done, check pointer will ask the background writer to write the corresponding information from shared buffers to data file. So your check pointer approaches the background writer and says something like this. Wall writer has written something from wall buffer to wall file. You go to shared buffers and write the same information from shared buffers to data file. Now what background writer does, it will go to shared buffers, copy the data from here to here. 21200. So this is 10th step. Once it is done, your background writer will again inform back the check pointer that yes, I have completed the data copy from memory to disk. Then check pointer, what it does, it writes information here, 2 and 2 matching. Your transaction is completed. Once the wall writer is written information from wall buffers to wall files, wall writer will inform the check pointer. Check pointer writes that information to control file. Then it will ask the background writer to write the corresponding information from shared buffers to data file. Once it is done, it will inform back the check pointer and check pointer updates the control file. Both are matching, done. Is this clear? Right. I'll come here. 1, 2, 3. Maybe this is my auto vacuum launcher. My data file. 1, 1, 100. Copy the data within the table. 1, 1, 100. That is my first step. This is my control file. This is my wall file. This is my first step. This is my second step. 2, 1, 200. And then 2, 1, 200. Display on computer screen that one record updated. And then this guy has written that information from here to here. 2, 1, 200. And this is marked as dead. Information is displayed on computer screen that commit complete. This guy informed him. He wrote 2 here. And this guy informed him. This guy has brought the data from hard disk to memory. And this guy is bringing the data down. And now my background writer job is to update the information in memory to disk. He has started bringing the data, and somewhere here there is a power loss. Understood?
Yeah.
Understood. I issued a commit. Information from wall buffer is written to your wall file. Sorry, written to my wall file. Commit complete message is displayed on my computer screen. That means my data is safe. And now my background writer is wanted to flush the data from disk to, sorry, memory to disk. It has started bringing the data to 200 from memory to hard disk. Before it writes it to hard disk, my system crashed or there is a power loss. What happens when there is a power loss? Your RAM content is gone. RAM is a volatile memory. You restarted your phone, your RAM content is gone. That means this 200 is gone. Any questions? Understood? Yes, no, maybe.
Yes.
Okay. And I have restarted my computer. I do select star from employee. What will happen? As per our select statement discussion, what will happen? Quick.
It goes for recovery.
Let us assume it has not gone for recovery. What will happen?
Do we have any redo file concept? I mean, here. I mean,
Your wall is a redo one. Wall is a redo data.
redo. Yeah. I mean, like we do
Oracle,
a.
it is a redo log.
Yeah.
Postgres, it is a write ahead log or a wall file.
Okay.
Okay. Yeah, let us assume that it has not gone for recovery, redo, and all that stuff. What will happen? Just for time being. Understand? What data I'll get when I do select star from employee?
If it is not go for recovery, then we will get old data only.
You will get 1,100. This data.
Yes. Yes. But it should go for roll forward as once we
Correct.
start instance again.
Correct.
We
So
have
since
data
the data is committed, that means the modified record is there in my redo log. Modified record is there in my redo log. There is a 2 number here, and there is a 1 number here because my background writer hasn't written to check pointer, right? So when you restart, the first thing that your postmaster does it will go to your control file and it understands that this number is greater than this number, which means there is a modification made in the wall file is not yet updated to my data file, but the content in the memory is gone. So what it will do, it will copy this data from here to here. You call this as instance recovery in Oracle. Here also the name, its name is same, instance recovery. Your instance recovery is happening from wall files. Once the data is copied from your wall file to data file, you will get 2 number here. That means 2 and 2 matching. Now you are open for external connections. Until this copy is done, your system is not open for external connections. So you'll get 200 copied here, 200. System is open for external connections. Now you do select star from employee, you'll get 2,200. Understood? Yes. No. Hello.
Yes, Kumar.
Right. Now, point is when you are doing select, what is happening when you are doing select? You have your memory, shared buffers, you have your user backend process, you have your data 1,100, and you're just bringing the data from hard disk to RAM, and you're displaying on computer screen. You're not doing anything extra. But when it is update, this entire layer came into picture. You have all buffers came into picture. You have a bunch of background processes came into picture. You have control file, wall files, and all that stuff, right? This extra layer is for two reasons. One, it is for fastness. So with this extra layer, your transaction will become faster. Two, for point in time recovery, PITR, because the data is stored in append mode in wall files, whereas it is stored in replace mode in your data files. Right? This extra layer is for fastness, and this extra layer is for what do you call point in time recovery. Any question?
Kumar, do we have this role of this both processes in HADR as well? Like so many concurrent transactions are going on, so I want to
No,
increase
there is only
frequency.
one process that sends data over the network from your primary to
Mm-hmm.
standby. So
Right.
in Postgres, at the moment, you don't have multiple recovery processes. There is only one recovery process.
Mm-hmm.
So your HA is lagging. You have two reasons. What is the capacity of your network speed, and what is the rate at which you are changing the transactions?
So
If the
the
rate,
yeah, sorry to interrupt. That rate is decided in any parameter like time or some storage like MBs. What would be that?
you can calculate that.
Okay.
So based on your calculation, select, for example, select PG,
Mm-hmm.
current, Paul, LSN. So this is my current uh, uh, location at which my wall writer is writing the data to, right? I make
Okay.
few transactions. Let us say I'll do something like create table, employee ID int, salary int, employee is already there. Then insert into employee of ID, select.
I assume all these commands are more of when we face some performance tuning or performance lagging issue.
Correct. So what I'm doing is I'm making changes. I'm making change, which means the
Mm-hmm.
change should go to your wall file,
Okay.
right? We are yet to understand the insert statement. Currently, what we are doing is we are understanding the update statement. Insert completed. And now let me check this. The number got changed. So what is the difference here? Select PG wall LSN difference of this and this. It is in reverse order. Let me do comma. So this change has generated 612 MB worth data, right? Now your network
Right.
speed, you can use any operating system level command to understand your network speed, or contact your network administrator, ask him what is the network speed that we have from machine A to machine B. If both machine A and machine B in the same zone, there is a one network speed. If both are in different zones, regional HA you call, right? One your primary will be there in one location, your standby will be there in some other location,
Right.
some other region. In that case, what is the network speed? For example, just now we have seen every time you create a session, it creates a new background process, which is called a user backend process. Now you have created 100 background processes or 100 connections, which means 100 user backend processes each process is writing data. Since it is within the machine from RAM to hard disk, everything will be faster. Let us assume all 100 connections are generating 2 Mbps data. That means 200 Mbps data is getting generated. Each connection is making 2 Mbps data, which means 200 Mbps data is getting generated within the machine. But your network speed is 100 Mbps. If that is the case, there is always 100 Mbps lag per second, and that gets accumulated over the period of time. After 2 seconds, you will see 200 Mbps lag. After 4 seconds, you'll see 400, and that gets accumulated. So what is the first thing that you need to see as a simple thing? We'll start with what is the speed at which the system is generating data? What is the speed at which it is getting transferred? As simple as that. You cannot do anything here. Only thing that you can do is reduce the speed or reduce the amount of data that is getting generated. You cannot go push your wall sender or a wall receiver, or you cannot go stretch your network. You got it, right? You talk to your Airtel, 8 Gbps is not sufficient. I get 16 Gbps. Talk to your client. So that's the only thing that you do.
But what in case my transactions are like some financial institution or something?
That is what
So many,
that is where discussion comes into picture, right? You have to
right?
show these artifacts to your customer client.
Mm-hmm.
See, you're generating your application is generating 100 Mbps data. You gave me only
Yeah.
1 Mbps bandwidth. How can this be transferred? You cannot transfer.
Mm-hmm.
What you can do, you cannot do an architectural change. You cannot increase your wall senders or a wall receivers.
Right.
There is only one process that will do recovery.
Because whatever I had in this session, I feel they are very core. So I just wanted to doubt if we can increase, reduce, or
No,
some setting can be done manually.
no. So there is only one
Okay.
thing.
Mm-hmm.
See, everything revolves around your configuration file. So there is nobody needed for you to tell there is any hidden thing or not. So everyone tells from the same configuration file. If
Mm-hmm.
there is any such option, wall sender or a wall receiver parameter, I can do recovery with multiple processes. You just increase that number, right? It is as simple as that.
Yeah, thank you. That answers my question.
Yeah, this I generally tell maybe in another 2-3 days that will come. So there is nothing. I mean, even on day one, I don't remember whether I told this or not. So there is nothing like I'll go ps-ef grep Postgres. You see a very big line with -t in between. Understanding PostgreSQL is nothing but understanding what is there in this location, understanding what is there in this location. As simple as that. So I'll go to this location. I'll understand there are a bunch of folders and files, and there is one file called postgresql.conf. I'll open this. When I open this, I understand that there are lots of parameters available. So just understand each and every parameter in detail. It takes 2 to 3 months, for example. And by understanding each and every parameter, you're done. No other textbook, no other performance tuning stuff will give you extra information.
Agree.
For example, there is something called pull_page_writes. This is something related to what we are discussing now. For example, I'll come here. Let's see the textbook definition of what this is. As per the documentation, when this parameter is on, PostgreSQL server writes the entire content of each disk page as it is to wall during the first modification of page after the checkpoint. So there is nothing like when you update, that information 1 comma 100 is extracted. I will write only that information. There is nothing like that. It will blindly copy your page, the data file, 8 KB, right? Data file is 8 KB. So it goes something like this. In your hard disk, this is my hard disk, 8 KB block, my table. I wanted to modify this. It is brought to memory, 8 KB. I modified this 8 KB is copied to wall, and this 8 KB is copied to your wall file. This is wall buffer. There is nothing like you open it, you do this, you do that. No, nothing like that. What this is telling, when you read it carefully, writes entire content of page since the modification, since the last checkpoint. So the page is modified after the checkpoint, it writes entire page. So you stretch your checkpoints so that the entire page will not get written to your wall file, which means the wall content gets reduced. One of the tuning stuff that you can do to avoid so much of information getting written to your wall file is increase the checkpoint. So this is Krishna question's answer. The question is, I always see the replica lag. So much of transactions are getting generated in the primary. My replica could not able to catch up. I cannot increase the bandwidth. I don't have money. What is the solution? The solution is to write less to your wall. How do I write less to my wall? Increase the checkpoint so that it writes less information to wall. What is the trade-off? That means what are the disadvantages of doing that? Understand that checkpoint timeout value. What checkpoint timeout? What is the advantage of putting that high value? What is the advantage of putting that low value? And all that stuff. It's as simple as this. Full page writes on what is the advantage and disadvantage, off what is the advantage and disadvantage. Checkpoint timeout, what is the advantage and disadvantage? Putting it on or putting it off. Whatever. Yeah. Next thing, I wanted, there is another thing. I literally wanted to see what is there in my wall file after I do update. You can actually see that, but that is beyond the discussion that is happening here.
So Kumar, just a quick question on this Postgres.conf file.
Hmm.
So don't we have privilege to adjust or assign dedicated memory like we do have MS SQL or some cases Oracle also to particular that instance?
That is what it is, right? This is shared buffers, the one that
Yeah,
we are discussing.
correct.
There is a value of 128, you modify it, simple.
No, I mean whole instance. It will create a for the whole instance, right?
This is instance level only, yes.
Yeah. And what about the page file size, which
8 KB.
is do we have privilege to extend that? I mean,
No, you cannot change that.
to just boost the performance.
No. Only during source code installation you can change it, but as we discussed, source code installation will not do in the production systems, so you cannot change that.
Okay. Thanks.
Right. Now I have a question here. Welcome. This is my 1 comma 100, or sorry, 2 1 200. And then this is 2 1 200. This is my background writer. This is my wall writer. This is my data file 1 comma 100 was the previous value. This is my wall file. Right? Let us assume you have a very big table with so many pages, and this is the page you actually wanted to modify. And yeah, it is there somewhere here. Let us assume this is the page you actually wanted to modify. Question to everyone. My background writer will do that. Assume that the time it takes to travel from here to here is 2 seconds. Assuming that the time it takes for your background writer to travel from memory to disk is 2 seconds, and then find the exact location in your very big table and modify that value, it takes 10 seconds. 2 seconds for traveling, 10 seconds for finding the exact location and replace the content. Total, how much time it takes for your background writer to update the data? Do you want me to repeat the question? Or you don't want to answer?
Can you repeat once again? Sorry.
See, we understood that background writer writes information from memory to disk, right? Memory to your data file. Assume that the time it takes to travel from memory to disk is 2 seconds. So it has traveled from here to here in 2 seconds. And after reaching the disk, to identify the exact table, exact location where it wanted to modify, or exact page where it wanted to modify, it takes 10 seconds. Total, how much time my background writer takes to refresh the data from memory to disk? If you want, you can use the chat as well to write. Quick. How many of you have not understood the question?
It could be a 14 second.
Where does 14 came from?
I mean, it's has to implement.
Any other answer?
More than 12 seconds.
It is 12 only. 2 seconds for traveling, 10 seconds for finding and pasting. 2 plus 10. Now the point is, what if I ask my background writer to throw it wherever you want? How much time it will take?
No, that case it should be insert only.
It is insert. No. Same example. You don't think insert, update, delete, whatever. The same example. Find the exact location and then refresh that page. 10 seconds. Traveling 2 seconds. Total 12 seconds. I told background writer, throw it wherever you want. How much time it will take my background writer to do that?
3 seconds, Kumar.
2 seconds. Only traveling time, right?
Yes.
Correct.
Right. Only traveling time, you throw it wherever you want. That is what exactly your wall writer is doing. Wall writer, what it is doing, this 21200, it is bringing it, putting it here, 21200. Next modification, it will write it here, 31300. Next modification, when this wall is full, it creates a new wall and it will put it here, 41400. So it will just go throw it into your wall file, dump it. But here you are modifying page and all that stuff, right? Hence your transaction with this extra layer is faster compared to this. You are sending money to your friend or you are purchasing something in Amazon. Without this extra layer, this will remain for 10-15 seconds. With this extra layer, the end user is going to see this within 2 seconds. You're happy with this, right? Not this. Your transaction is in progress. Don't hit refresh button. When your extra layer is not there, that will be 10-15 seconds. When extra layer is there, your money is sent. Money is sent means your modification is done in your vol file. I least bother about the modification is made in the page or not. Right? As an end user, I don't bother about that. Money is sent, simple. After that, 15 seconds behind the scenes, your background writer go plus the data from here to here. Hence, your background writer is called as lazy process. You have dbwn, but here it is only bg writer, only one. At least since it is lazy, you have n here in Oracle. And the second, as I said, you have point in time recovery. Let us assume this is your wall content. The first change I made 1, 1, 100. Second change I made 2, 1, 200. Third change I made 3, 1, 400. Fourth change I made 4, 1, 500. Fifth change I made, it has become something like this. At this point in time, I can take my database to any time in the past as long as the walls are available. I can take my database to second position. I'll ask it rewind. Point in time recovery, you call that as. So because of these walls, you have two benefits. One is fast. Two is you can do point in time recovery because it is getting appended. You can revert it anytime in the past, anytime in future. Clear? Assume that the above one is your memory. This is your data file, control file, and wall file. Assume that 46 is the transaction ID. Is this situation possible? Quick. Open forum. Next 5 minutes. Is this situation possible? Do you don't want me to continue? Is this situation possible? Yes, no. That's it from my side for today. Any casual questions?